Good morning, everyone. Thank you for joining us. My name is Nathan Heston, and I'm a trainer here with Briggs & Stratton Energy Solutions. I'm joined by my colleague, Daniel Moyer. Daniel, good morning.
Hello, Nathan.
So the topic today is whole home backup, featuring the Sol-Ark 15k and SimpliPhi batteries. And we have a number of different battery options that we're going to be going through. We'll talk about configuring the Sol-Ark 15k with our battery options. Giving just a minute for people to get in, but as I wait for people to trickle in, I want to highlight that this is a NABCEP approved talk. So if you're looking for those continuing education credits, please stay through. And at the end, we'll give you our email. Please send us your email address. Let us know how you would like your name to appear on your NABCEP certificate, and we'll generate that certificate and get it your way. As we get started, I want to point out that if you have questions and you would like to ask us those questions, please use the Q&A feature of the webinar. So you should be able to find that Q&A feature in the Zoom menu on your screen. We encourage questions. We like questions. It helps keep these trainings interactive. So welcome, everyone. Looks like we have a large group of people joining us. We're going to go ahead and get started. Again, the topic today is whole home backup featuring the Sol-Ark 15k inverter and SimpliPhi batteries. As an overview, we're going to start off with the basics of energy storage. We're going to talk about what it means to do a whole home backup and what it's like to compare that to critical load backup. We'll show some examples of whole home backup. We'll talk about options with SimpliPhi batteries, both our non-communicating batteries and our communicating batteries. We've got a new battery as well, and we'll highlight a few features of that. We're going to talk about the Sol-Ark 15K's features, both its software and hardware features. And then we'll talk about sizing battery banks for whole home backup, as well as setting up the inverter, and then monitoring after your system is set up. And we'll highlight our Elite Installer program, where you can get $1,000 off your first SimpliPhi ESS system if you have not installed one before. So Daniel, Briggs & Stratton is one of the two companies in the US that makes both generators and batteries and inverters, right? We're one complete integrated energy solutions provider. What are some of the things that you like to point out about our company?
One is our history. We've been around for a long time, so we have an expertise in making power and application expertise. Another one is we have a global manufacturing expertise. So we have factories and engineering offices all around the world. So I'm really excited about the legacy that Briggs & Stratton brings, the power of the brand when it comes to making these sales with the homeowners, that people recognize a company. And yes, being one complete integrated energy solutions provider, doing both generators and energy storage systems makes us experts in both.
I really appreciate that, Daniel. So thank you for offering that. I'm not going to spend a lot of time on marketing in this talk, but we do make our batteries down here in Oxnard, California, just about 2 hours south of where I reside. They're engineered and assembled in the USA. And Briggs & Stratton's got a long history, as Daniel points out. So SimpliPhi Power has been making these batteries using LFP technology for almost 15 years now. We are one of the pioneers of LFP home battery backup in the US. And we realize that others are trying to follow suit as well, with even Tesla moving over to LFP batteries. And then Briggs & Stratton has been around for 115 years. It's a company that's there, that will be there to back up our extensive warranty. If you would like to see some of our products in person, I will be at Distributech in Orlando, Florida at the end of this month, February 26th through the 29th. We'll be demonstrating and showing some of our energy backup systems as well as our generators at this show, and talking about some of our larger commercial and industrial product offerings as well. So come see us at booth 423. If you do not have tickets, we can offer you free passes to the show. So feel free to reach out if you will be in Orlando and would like to come to the Distributech show. There's a QR code there. Go ahead and scan that. I'll also be giving you a copy of this talk afterwards, and you can use the link then as well. We'll also be at the NABCEP Continuing Education Conference. And Daniel, I know that this is one of the highlights of your and my year.
Yes.
NABCEP is all about education and keeping people up to date with the latest innovations with energy storage and inverters. Daniel, what are you going to be talking about at NABCEP?
So I'll be talking about off-grid living with SimpliPhi batteries. So I'm really excited about that. Not only do we warranty our inverter and battery systems for off-grid, but also our generators. A lot of generators are standby generators and are not warranted for off-grid use or prime power. So we offer that as well. I will say this, that this conference sells out every year. And right now there is a low ticket alert going out to you guys right now. And scan the QR code. And I'm going to hint at it. We're going to be having an after party on Wednesday. So reach out to us, stop by the booth, let us know, and we'll get you tickets to our after party as well.
And I will be doing a similar version of this talk where I'll be joined with a representative from the Sol-Ark training team to co-deliver a talk about using the Sol-Ark 15k. We'll have an hour and a half then and have more time to get into the details of multi-system installs, etc. So if you are going to NABCEP, please let us know, and we'd love to see you there. I also want to highlight, as we get going, our newest battery offering that's coming out. It's in the beta test period now, but we will be releasing this battery in the second quarter. And what you're seeing on your screen there is a 19.8 kilowatt hour stack. Those come in blocks of 6.6. So we're calling that our 6.6 battery. It's got increased power density and capacity per unit, improved performance. This is an outdoor rated battery. It's stackable, so it's very quick to install, less wiring needed. And then we've refreshed our inverter design as well, made some changes to the display, made some changes to other aspects of the inverter to continuously improve it. We've simplified some of the cabling as well. So what you're seeing on your screen is that new stackable 6.6 battery. It's not out just yet. They're still in the final testing period. But if you're interested in learning more about this battery, at 19.8 kilowatt hours and at the output capacity of this battery, it can provide greater power density. This is a very nice pairing for the Sol-Ark 15k, which is the topic of today's talk. So if you're interested in getting on our mailing list to learn about more about this battery as information is released, please use that QR code or use that link that you can see there on your screen when I send these slides out to you. So let's get into the topic of today. Let's start off with energy storage. So what is an energy storage system? An energy storage system, right, consists of multiple components. There's an inverter, which is kind of the central hub of an energy storage system. That allows you to take in energy from various sources, from stored energy from batteries, generated energy from fuels like natural gas or propane, solar energy, of course, energy from the grid, and pass that into the home to power the home's loads. And almost always now there's an app to monitor and control your system. Briggs & Stratton is developing an excellent energy track app that you can use on your smartphone to monitor your system. Sol-Ark Inverter also has an app for their system, and we're going to be talking a little bit about that. So the two core pieces that we're going to be focusing on today are the Sol-Ark 15k inverter, which is on the left side of the screen, and the various Briggs & Stratton energy storage batteries, so lithium batteries. These are all LFP batteries. So there are a number of parallels between backup power with generators and backup power with batteries and inverters. Both of these options give you the ability to have backup power. It can give you peace of mind knowing that you're going to have the energy if the grid goes down. You can continue your business activity having backup power. There are a lot of reasons why people would like either a generator or an inverter to do these things. You keep those critical appliances, that refrigerator, that deep freezer running in a power outage. But there are differences between generator offerings and inverter and battery offerings. And so the parallel kind of breaks down once we start looking at payback, right? An inverter allows you the ability to do a number of different things like energy arbitrage. So here in California, we have variable electricity rates. My electricity is 42 cents at base, and then it goes up during peak times. So typically in the evenings, my rates go up by about 6 or 7 cents per kilowatt hour. I know these are expensive prices. They're even more expensive in places like Hawaii or Puerto Rico when you're on islands where the generation methods are more difficult. So you can buy energy when it's cheap and use it when it's more expensive to prevent having to buy at those higher rates. You can also, of course, pair an energy storage system with renewable energy resources that are typically you have a capital investment, but then you can get that energy for free, like a solar array, right? And so with a solar array, with energy arbitrage, your inverter and battery system can pay for itself over time, right? That's a difference to using a generator with some fuel system, is that the generator doesn't pay for itself over time. Not that that's a bad thing. That peace of mind might be worth it to have that generator, and you get very long run times out of a generator. But there are also government incentives that you can take advantage of when you're installing an energy storage system. And so keep those in mind. And if you're looking for information about those things, please reach out to your energy solutions representative, and we can help you with those. We have somebody in-house who looks at and follows the details of the different incentives around the country. What do we mean by whole home backup? So there's many people will buy battery backup system for their home, but not realize that it doesn't power everything in their home, right? Now, most of you that are on this call probably are well aware that you can use a small system to back up some of the loads in your home, but not necessarily back up the whole home. And why is that the case, right? Well, with a partial home backup system, you essentially don't have the ability to pass all of that energy from the main panel through the inverter to the loads. And so for a smaller system like the Briggs 6K that's featured on the left side of the screen, your inverter has batteries. It does pass some of the main panel energy through to the core critical loads. But if the grid goes down, essentially what happens is the inverter isolates itself from the grid. It islands itself. And it still allows solar to come in, charge the batteries, power the loads that are in your core critical loads panel, but it doesn't power the main panel in a grid outage. The nice thing about the Sol-Ark 15k is the Sol-Ark 15k has a 200 amp pass-through, and it allows you to pass all of the electricity from the grid down through a disconnect through the inverter and power the main panel of the house. So if the grid goes down with the Sol-Ark 15k, you isolate from the grid, you island yourself to protect from harming somebody, the line worker that's on the grid. We don't want to feed back to the grid when the grid is down. And so this system isolates itself and allows the batteries to power the entire main panel of the home. Now we have to make sure that the main panel of the home doesn't draw more power than the batteries are capable of, or the inverter is capable of. This inverter is capable of 12 kilowatts of power from batteries and an additional amount of power if solar is also available, producing a total of 15 kilowatts of output from solar and batteries in a grid down situation. Here are a couple of examples of whole home backup. I've pulled these from the web. There's an example on the left with some of our older batteries there. And that looks like actually a Sol-Ark 12K that's featured there. And on the right side of the screen, you can see a Sol-Ark 15K with one of our Boss 12 cabinets. And I'll talk to you about those battery offerings with one of the span panels, which offers smart load technology as well.
One thing I wanted to point out, Nathan, if you go back a slide, is that notice the positioning of that Sol-Ark and the battery. They've positioned it in such a way in that garage that it's kind of near that wing wall where they not necessarily need to install a parking bollard, which is becoming more common with our inspectors, especially if that's a pre-tensioned concrete pad there. Last thing you want to do is start drilling into some rebar in there. So just wanted to point that out.
Yeah, and that is an important point, Daniel. When you are installing batteries in garages, you do need to protect those batteries, right, for safety reasons. If somebody pulls into the garage without paying much of attention, they could run into those batteries, and so some jurisdictions are requiring parking ballards for that. Let's talk a little bit about the history of inverters and why this Sol-Ark 15k is kind of a game changer, right? Most battery backup for homes, it got started in the off-grid world. It got started before these grid-tied systems, and I believe around, Daniel, was it 2000 or so that they started developing grid-connected inverters in Arizona?
Yeah, late 90s was the first interconnection agreements that came about in California and other parts in the West.
Thank you. And so you can see these inverters, and there's some great inverters on the screen. I'm showing you the Tesla Powerwall on the left side at 3.3 kilowatts of output, and then this Powerwall 2 with 5 kilowatts of output. I'm showing the Schneider inverter there at 6.8 kilowatts. That's the XW Pro. Believe is that a Xantrax or a Trace up there in the top, Daniel?
That's an old Trace.
It's an old Trace inverter, 4 kilowatts. Some of the SMA inverters were getting a little bit larger in size, and you'll notice that these inverters have been growing in size, and I do believe this trend is going to continue, especially as we move to more and more electrification. Right, Daniel and I, just before this talk, we're talking about cars and car chargers and the capacity of car battery banks. And so I want to point out that it doesn't seem like this trend is going to reverse, right? Most customers are looking for plenty of power to be able to power their home in a grid outage. And in some cases, that 15K is not big enough, right? If you've got a house with a number of large loads, like a number of large air conditioners, you will need more power. And so you can parallel the Sol-Ark 15K and the 12K options. You can parallel up to 12 of those inverters to get very large systems. I'll show you a few examples of that. In terms of battery limitations, batteries have a storage capacity, but they also have output limitations as well. So typically batteries are rated at a C/3, C/2. Our batteries are C/2 power limitation. That means that you can draw the power out of the batteries as fast as in 3 hours or 2 hours. And the battery on the right, our newest battery is going to be offering a considerably higher power draw rate. I believe it's going to be a 1C power rating, which means that you can discharge it quickly because it's designed in a way to be able to provide that power without damaging cells. So it's important to keep those batteries in mind as well. Not only do you have to have a large enough inverter to power the loads in the home, but you also have to have a battery capable of delivering that power. So we'll talk a little bit about sizing later. The last version of this talk, I spent some time talking about all the loads in the home, the typical loads, heat pumps, well pumps offering kind of big inductive drains on a system that can spike. And the Sol-Ark 15K has a surge ability. It can do 24 kilowatts from batteries for up to 5 seconds to start those large inductive loads like large air conditioner compressors, etc. But typical loads in a house can add up. However, the average use of a home is about 1,200 kilowatts. At least it was last year when we pulled this data. Keeping in mind that some systems like electric ovens, induction stoves, water heaters can add considerable draws on an electrical system in a home. It's important to consider these. And then the one thing that I didn't put on here that I would like to have put on here is car chargers, right? Daniel, you said the size of the Nissan Leaf battery is a 40 kilowatt hour battery.
Yeah, that's right. And another point I want to make on this is some of these loads here aren't on continuously. For that refrigerator, for example, it's going to cycle on and off over the course of the day. So although it may consume 500 watts or 200 watts, over the course of the day, it might consume 1 kilowatt hour. And also, as we're thinking about some of these loads, do you have a gas water heater, a gas furnace, a gas oven? A lot of these main energy draws is really heating and water heating of your home. So take a close look at what the demands are on the home, and then design a system that's really going to set the expectations.
And when we're thinking about a whole home, we do have to think about all of this. And I did put gas furnaces on there. You're probably wondering why I have gas furnaces on there. I really shouldn't have called it a gas furnace. I should have called it the blower motor on the furnace, right? It's really that electric blower motor that circulates the air. And I can attest to that, the fridge that is on your screen there, Daniel, when it is running, that's the exact fridge that I have just to the right of me here in my kitchen. And it really only does draw on the order of it's maybe 150 watts when it's running. And then the duty cycle, like you said, it's not on all the time. Laundry is very rarely on, right? But when you do kick it on, are you going to overload your inverter? So when we're looking at backing up the entire loads panel of a house or large amounts of those loads, we have to consider sizing our inverters and batteries to be big enough to do this. One way to be able to power more of your loads is, of course, to parallel multiple inverters. The Briggs & Stratton inverter that you see on your screen, we can parallel up to 4 of those. 2 of those will give you 12 kilowatts of output power. But the downside to this configuration is that we only have 40 amps of pass-through per inverter. So in this example that you can see on the screen, we only have a maximum of 80 amps of pass-through, and that's not enough to be able to power the whole loads panel of most homes. In an off-grid situation, you might be able to get by with a smaller amount of pass-through like this. And this is a good option for some of those smaller homes. In fact, just a single one of these inverters is what I'm running in my house here. And it's a good option for powering a subset of the loads of my home. Here's an example with a Sol-Ark 15k. The bigger difference here, the big difference is being able to bring the power from the grid, right, from your meter through a fused disconnect into that inverter and being able to pass 200 amp service directly to your main panel. So this is a very nice feature of the Sol-Ark 15k, and I believe one of the big reasons why this inverter is so popular. I'm also showing on the screen here a disconnect for that solar array. However, there is a switch on the side of the array, so you might not need that switch unless the local housing authority is asking you to have a disconnect on the outside of the home if you've mounted this inside. There's also an emergency shutoff that you can integrate into both the Briggs inverter and the Sol-Ark 15k inverter. I'm showing this with Sol-Ark rapid shutdowns, but I don't think they're out yet, and I believe this is a picture of AP Smart rapid shutdowns. I think that the Sol-Ark options are a bit different looking. I'm also showing it with a Boss 12 cabinet. So this is featuring 12 of our Phi batteries there. And the Phi battery has been a very popular battery. The AmpliPhi battery would come with communications through CAN bus and be able to communicate with the inverter the desired properties. I'm also showing the PV monitoring app here on the right side of the screen. Sol-Ark has a nice setup that allows you to monitor coming in from a generator. It allows you to bring in an 80 amp generator through that, I believe they call it the smart loads port inside that inverter. So you can bring 80 amps from generator pass through to your loads in a grid down situation. You can also bring in AC coupled solar. I'm not showing that here on the screen, but if you do have a retrofit, maybe there's already an existing N-phase system on the roof, you can bring that in through that Sol-Ark as AC coupled. And then if the grid goes down, unlike with a normal AC coupled system, when the grid goes down, you lose that solar power. Having a battery system allows you to keep that solar power going with AC coupled solar. And the AC coupled solar and DC coupled solar on the Sol-Ark are independent of each other. So you can bring in 19 kilowatts of DC coupled solar, and you can bring in up to 19.2 kilowatts of AC coupled solar. Depending on the size of your battery bank, though, you might want to limit the amount of AC coupled solar you bring in through the Sol-Ark. So let's talk a little bit about our battery options that work nicely with the Sol-Ark. So first off, I want to point out that we have a 15-year unlimited number of cycle warranty on our communicating batteries. We use LFP technology. We use cylindrical cells because that's what makes our batteries last the longest. We're delivering the highest quality battery that can be made to you. and we're giving you that best warranty in the market. And I want to point out that although a few of our competitors offer a 15-year warranty, they often have throughput limitations or number of cycle limitations on their batteries. There are no limits, no throughput limits for all of our communicating batteries. And after 15 years, we're still guaranteeing 70% of your original battery capacity remaining. We can do that. We can offer this good warranty because we're using the best in the class lithium-ion LFP battery chemistry. We're using a very advanced battery management system, and we're using that most durable form factor. We have a number of battery offerings. Of course, we have the new one I was showing you as well that's coming out soon. But I want to point out that our batteries are manufactured here in Oxnard, California, and we are approved. We're a CPUC recognized California battery manufacturer. And so if you're doing an installation in California, you can get an extra 20% rebate off your batteries by filling out this SGIP application. We do not yet have it on the 4.9 battery. Yes, it is manufactured in Oxnard, but the paperwork is still underway to get that 4.9, the same SGIP rebate. So we have non-communicating batteries as well. And so if you're looking for a lower cost option, the Phi battery is the workhorse in many people's homes around the country. We have several 100,000 of these batteries, I believe, installed worldwide. We have a very large number, at least 100,000 of these batteries out in the field powering homes across the country. Our SimpliPhi battery is our smaller format communicating battery. It offers more insight into what's happening inside the battery, and it can communicate directly with Sol-Ark inverters, as well as our own inverters and our apps. The Phi battery, you can do almost no limit on the scale. I'll show you a few pictures later of very large systems using the Phi battery. You do have a limit of about 60 batteries on the SimpliPhi battery, and that has to do with the communications equipment on those batteries. The same BMS in the SimpliPhi battery also appears in the 4.98 kilowatt hour battery. The difference between these batteries is, one, the 4.9 battery is a wall-hung battery. You still have a limit of 60 batteries there. You can do up to 300 kilowatts of storage with these batteries. Outdoor rated, wall-hung. The SimpliPhi battery is indoor rated battery, so if you're going to put that outdoors, you need to put it in an approved cabinet, and we have some offerings for that.
Nathan.
And then we have a new battery that's coming out soon. You can see a 20 kilowatt hour stack there on the right side of your screen. That's our 6.6 battery. That 6.6 battery will be out in a couple months, but it is outdoor rated. It is wall mountable or stackable floor mount. And like I said, that will be shipping in the second quarter.
Hey, Nathan, I wanted to just chime in. One, we had some concerns that my mic wasn't working very well, so I hope I'm coming through a little bit better. I changed it up. One, I want to encourage everybody to use the Q&A feature. We're here. We want to keep these interactive, and people, please put in some questions if you have any sort of questions. I can't unraise your hand, so just go ahead and throw them into the chat. And that brings me up one thing is, you had mentioned just a minute ago that you could use a non-communicating battery with the Sol-Ark. So why would somebody maybe want to do that? And is it, what are we losing? What are we gaining? Why would we want to use maybe a communicating battery over a non-communicating battery with the Sol-Ark that is able to talk? Maybe we talk a little bit about that.
Well, that's a great question, Daniel. So, I mean, one answer is cost, right? You can get a non-communicating battery at a lower price point. And a lot of times you don't need that advanced communications. Communications give the battery an ability to do things like control its output rate or recommend output rates to the inverter based on internal temperature. They give the inverter ability to surge, knowing that your battery is kept safe. With a non-communicating battery, the inverter is moving ahead with kind of preset settings that may or may not be appropriate for the conditions that the inverter is currently in. The communicating batteries also allow you to monitor remotely. They alert you if there's anything awry with the system that might need attention. And so there are a lot of advantages to using communicating batteries, but the non-communicating battery also has its place. And if you know that your system is in a location where the temperature is accounted for, it can be a great option, and you can get more capacity for less money that way. So I appreciate the question. If you are going to be installing outdoors with either the Phi or the SimpliPhi batteries, because these are not outdoor rated batteries, you'll need to put them in an enclosure. These are NEMA 3R enclosures. They're UL certified. We do a lot of safety testing on all of our equipment, our batteries, as well as our inverter, our battery cabinets. And so these batteries, what you're seeing on the screen is a Boss 12 cabinet and Boss 6 cabinet, which will both fit 6 and 12 of those 3.8 batteries, either the communicating or the non-communicating. And one of the nice things is all the wiring's already, the components are already there, the combiners, etc., inside these cabinets. We can use the Boss 12 cabinet as an access cabinet and essentially have 6 batteries inside it. This is a popular option for both our inverter and the Sol-Ark 12k inverter, or even the 8k inverter. Is that you can put them inside these outdoor enclosures and really have a pretty close to plug-and-play solution that's UL 9540 certified, etc. With the Briggs & Stratton energy storage system, it comes with our well, you can use it with our 4.9 battery. You can use any of our battery options with the Briggs 6 kilowatt inverter. It also comes with the Energy Track control system, which allows you to remotely configure and fleet manage from the power of just your mobile phone. But with the Sol-Ark 15k, there are a number of things that set it apart. It has effortless communications with all of our Briggs & Stratton SimpliPhi batteries. It allows for very easy commissioning, having that communications. It's indoor-outdoor rated. All of the components on this unit, the hinges, the bolts are stainless steel, high quality. It's IP65 rated NEMA 3R inverter. You can do 12 kilowatt battery to loads, 15 kilowatts of power when you've got PV available together with batteries. You can surge for, I thought it was 5 seconds. I guess it's 10 seconds at 24 kilowatts of power. So it's a lot of power to start up those larger loads. You can bring in 19 kilowatts of solar from the DC side and an additional 19.2 kilowatts of AC through the Gen port or the Smart Loads port. It's got 200 amp pass-through. It's 80 amp, I believe, on the generator Smart Load port. They've specified it a couple of different ways, but I do believe it's 80 amps, not 100. It's 19.2 kilowatts. It's got automatic 2-wire start that can be utilized to run Briggs & Stratton generators. You can stack these inverters up to 12 of them in parallel. We've got a long history of success with our batteries and the Sol-Ark inverters. So how would we size the Sol-Ark 15k with our batteries? I'm going to get into wiring shortly here, and I'm going to talk about the connections with the Sol-Ark 15k. But I do want to talk about sizing, because that's one of the principal things you have to get right when you're putting a system together. A lot of homeowners want to save money by skimping on the batteries, maybe start with a smaller battery system. You have to make sure that the batteries have enough output power capacity to be able to deliver that 275 amps that Sol-Ark wants when it's at full battery capacity, when it's running 12K out of the batteries.
And that's a question we just got, Nathan, is do I have to have a minimum number of 4.98 batteries, 2, for example? And can we have less than what we show here on the screen?
Yes and no. So if you're using the non-communicating batteries, we do require you to have a minimum number. You can program the inverter to draw less power than the maximum, right? So for somebody who wants to start off with a Sol-Ark 15k inverter, but start off with a smaller battery system, you can program that Sol-Ark so that its output capacity is less than the 12 kilowatts. However, to keep your warranty, you need to make sure that you program that inverter appropriately so that you're only drawing the amperage that the batteries allow. So those 48-volt Phi batteries allow you to draw 37.5 amps continuously, right, per battery. So you'll need to program, yes, you can go smaller, but you'll need to program the inverter appropriately. And we really recommend going with that minimum number of batteries. With the communicating batteries, those batteries automatically communicate their programming rates to the inverter And so in that case, we often have people that are undersizing the battery systems with the intention of adding more batteries later on. So yes, you can undersize. However, you'll need to program the inverter appropriately to maintain your warranty. I hope I've answered that question. I would not recommend using just 2 of the 4.9 batteries. Those 4.9 batteries at C/2 are delivering 2.5 kilowatts each. So if you are using just 2 4.9 batteries, you'd be severely limiting the output of that Sol-Ark inverter down to 5 kilowatts, right, when it's capable of doing 12. Additionally, you know, if you are running the whole home off of 2 batteries, you're not going to get much runtime by doing that. So you'll get an overload error if you're only running a couple of batteries, if you're trying to draw too much from it, and you're not going to get much runtime. However, because of the communications, we do allow you to undersize a system. We have our recommendations that are there on the screen. I'll also point out that the 6.6 batteries that are on the right side of the screen there are going to have a considerably faster discharge rate at about 1C. So that 20 kilowatt hour battery bank that's shown on the screen can produce a lot more power output, nearly 20 kilowatts of power output. There are some limitations that will be on the power distribution unit that's shown on the top of that battery. I don't have all of those exact specs yet, so I can't give you the recommendations. However, one of those battery stacks I can confirm will power a Sol-Ark 15k. So here are a couple of examples of multiple inverter systems. So you can do, and these come from our some of our installers. So Wolf Creek Solar Electric has done that one on the left side of the screen. I believe that's 80 of our 5 batteries together with, those are Sol-Ark 12Ks, and I believe there are 8 of those units there. That's done at an installation in Alaska. On the right side of the screen, you can't see all of those inverters in that larger picture, but there are 90 of our 5 batteries there and 7 Sol-Ark 15Ks there run in parallel. And that's another nice example of a larger system. We're not going to focus today on paralleling systems, but I will talk about it. Daniel, any more questions that have come in?
Yeah, one a little bit related to undersized batteries. So say we did have a Sol-Ark with maybe an undersized battery bank, or maybe it was an appropriately sized battery bank. And what happens if the loads exceed the ability of either the Sol-Ark or the batteries to provide power to the home?
With grid up or grid down?
A grid down situation, I believe is what we're asking here.
So if there's grid down and there's solar available, it can use the solar, of course, to power some of those loads. So you can saturate the DC bus with 15 kilowatts of solar coming in, 19 kilowatts of solar coming in, and 15 kilowatts of that can be used to power loads and charge batteries. If solar is not available, and you exceed the power output of the inverter from batteries, and grid is not available, if you have a generator connected, it will start up the generator. If you don't have a generator connected, you can get into an overpower situation and the inverter can restart with a fault. So that's why I'm saying if you need that full power output of the inverter, that you should size your battery bank appropriately. However, if you have a small draw on your system, you could use an undersized bank, just knowing that in a grid down situation, you're not going to be able to power all of your loads. Okay, so there are a lot of variables to that question. I hope I've done it justice. We can talk more about it at the end. But there are kind of some minimum sizes that we would recommend doing for this inverter. If you're looking for a smaller, less expensive system, you can always install a smaller system like a Sol-Ark 8K or a Briggs & Stratton 6 kilowatt and just back up part of the home.
Yeah, or a load shedding device like we saw with that span panel as well.
Exactly. So that's the other thing that you can do is if you have a load shedding device, you can reduce your loads by having some of those loads shed under high demand times. And so that's one of the values of having a smart loads panel like that span. That being said, if you do not have a generator, you can use the generator port as a smart load port. So I'm showing the connections here on the screen, but while we're on the topic of it, you can use the generator port as a smart load port and select to have that port automatically shut down in too high of a power demand situation. So I would recommend, if you have a very undersized system, that you would use this port for that if you are not connecting AC coupled solar or a generator. So let me highlight some of the connections here. If you've not seen the inside of a Sol-Ark 15k, there's a lot of working room inside. It's fairly nice to work within this unit because there's a lot of room to run your wires, to run your cabling. So I'm going to point out the main parts. First off, people are sometimes confused by the fact that there are two 200 amp breakers inside the Sol-Ark 15k. These are here so that you can protect your 2-watt wiring coming from battery banks. So if you're using, you can use 2 sets of 2-watt wiring and have those 200 amp, utilize those 200 amp breakers. So you could have 2 independent sets of 200 amp, of 2-watt wiring coming into the batteries to the bank independently, and use this battery connection as a combiner. So you'll notice that there are 4 connections there. You can also buy these combiner bars if you want to have a single home run to the inverter with a 4-aught connection and combine these two, utilizing just a single battery connection. In the center of your screen, you have the DC inputs coming from your solar. You have 3 independent MPPTs, and there are 2 parallel connections for each MPPT. So having a total of 6 connections there, plus and minus for 6. The paralleling communications, if you're going to parallel a couple of Sol-Arks, these 2 ports in the center of your screen are used for paralleling, and you'll just daisy chain these. So if you have 3 inverters, inverter 1 to inverter 2, inverter 2 to inverter 3 back to inverter 1. So neither of these ports would ever be open if you have parallel communications. I'll talk about the DIN rail connections here. I'll talk about the connections here for things like AGS, etc. in a minute. But before I get into these dip switches, let's talk about, there's a CAN bus connection. So if you're using our communicating batteries, this is where that home run from the battery bank to the inverter would be. And this is the communications port where the battery and the inverter communicate to each other. On the right side of your screen, you have the AC connections in the inverter. So there is, starting at the bottom, there's a neutral, and there's a neutral bar down here at the very bottom to connect all your neutral. Your neutral ground bar should be inside your service disconnect. So that's that 200 amp fuse disconnect where you first come out of your meter. And then you have a separate grounding bar here for the inverter. You have the generator and smart load connection on the left side of the screen here. And then your loads output is here. It's fed with a 200 amp breaker. You'd feed your main loads panel out of this connection. On the right side of your screen, this is coming in from that fused service disconnect. So this is just to remind you, I showed this wiring diagram earlier, but this is what your connection looks like, where you have that fused disconnect coming from your meter, going into the Sol-Ark inverter, and then coming out of that Sol-Ark load port to your main panel of your home. So in a grid up situation where you have no batteries, you have no solar, you're passing all of that power from the main utility port through to the main loads panel of the house. When you have battery power available, you can set it to use that battery power to reduce the burden of drawing from the grid. And if you have solar available, you can use that solar to power the loads and charge the batteries if there's excess solar. Some other parts that you might want, if you're combining large battery banks, you might want to consider a large DC combiner. If you do not have one built in, there are some other recommendations for doing that as well. For using these power distribution boards is another option for combining those battery banks. Communications between paralleled Sol-Arks. This is a simple example. You could be running that 200 amp service. You're going to parallel that and run one to each inverter. And then those 2 inverters, one of those would become the master and the other would become the loads. You could use a power distribution board to combine those loads and send them to feed that main loads panel. I recommend installing these inverters with wireways. So I'm showing you an example here. This is a 12 by 12 wireway. So there's a fairly large depth to this inverter compared to some of the others on the market. The inverter's footprint is typical, but the depth is a bit bigger. So with a 12 by 12 wireway, it makes it fairly easy to make the knockouts in the bottom of the inverter match up to the wireway. And inside that wireway, you can mount your power distribution boards with those compression fittings for combos, especially when you're doing parallel units. The dimensions are here on the screen. You do need 6 inches above and below the inverter. So we're barely getting it here with this design. To the left and to the right, you do not need much space. The cooling fans on this unit are on the bottom and they blow that air up through the top. So there's only 2 inches of clearance needed on the sides. So you can put these inverters fairly close to each other, but you do need to give that 6-inch clearance on the bottom. I put on the screen just as a resource for you that knockout. You can buy a knockout template. I'm showing the knockout template here in the top right. That's available from, I believe it's Practical Prepper store on Amazon. And so if you're looking for that knockout template to transfer to the wireway, if you're doing a number of these, it's nice to have as opposed to having to measure it each time. Daniel, any questions?
Yeah, a couple great ones. This is kind of a good one. Inverters have an efficiency related to them, right? When you change from DC to AC, you lose something. Does the amount that you lose change based on the output of the inverter, whether it's just doing a little bit of work or a lot of the work? Is that a linear kind of efficiency on that inverter load output? And I got another question after that.
Yeah, that's a great question that I'm not sure that I have a completely informed answer on. But I can tell you that round trip efficiencies on AC coupled systems are typically in the 85% range. Round trip efficiencies on DC coupled systems are round trip, meaning coming from solar, going into the batteries, out of the batteries, back to power loads, are typically in the 90 to 95% range. Each time you do an inversion, there's some amount of that energy is converted into heat. So if you're going from solar directly to loads, that's where you can get that 98% efficiency on the inverter. You're not using it to run the charging equipment inside the inverter to charge the batteries, right? So it kind of depends on output. If it's going from solar to batteries to loads, you lose a few more percent. If you're using AC coupled solar, you lose an additional maybe 10%. So I think that's the best I can do with that question because I'm not better informed on the topic.
Yeah, thank you. Another one from Frank. It says, please explain how load shedding devices, how they drop loads and why and when do they drop loads? And I think I'll handle that one is a lot of these load shedding devices are pretty intelligent and they're using certain, whether it's exceeding the amount of power that maybe is being drawn upon the inverter, but it can also trigger load shedding devices based on the remaining capacity in a battery as well. So there's lots of ways to do these load shedding devices that are becoming more intelligent all the time, and that could be a training in and of itself, Nathan, that we could do coming up. So stay tuned for something like that if that's something that interests you.
Absolutely, and I think one of the reasons why we haven't done that training in the past, Daniel, is we don't make a product like the SPAN panel. We have former colleagues are working with SPAN, right? And we have connections with SPAN. We do make a load shedding device for our generators with our transfer switches. And so that load shedding device, once a certain amount of power is exceeded, which you can set, it will drop loads in an order and a priority that you can set as well. Let's keep going because I have a few more topics I want to get through with everyone. When you are doing closed loop communications with our batteries, there are 3 different ports on the top of our communicating batteries. One of those ports is labeled device, and it's to go to the inverter. So this port that I'm highlighting that stands off by itself is the device port, which gets connected by one battery. You only need to connect one battery to the Sol-Ark 15k inverter. Keep in mind that the other 2 ports should always be filled by something, okay? So we go battery to battery. This is called daisy chaining. We go battery to battery. So battery to battery, battery 2 to battery 3 to battery 4. But those last batteries, those should have terminating resistors in the end. You should not have an open port on that battery. And so those terminating resistors, you get one with every communicating battery that you buy, and you'll need to have a terminating resistor in that port. The other connection is going from the device port into the CAN bus port of the inverter, which was shown earlier. So keep that in mind. Now, Daniel, we talked a little bit before about these dip switches, or these pins here. These smaller pins, these communication pins, can be used for various operations, such as you can use these with some of these pins are for the rapid shutdown devices. So pins 11B and 12B are a normally open rapid shutdown device. So it's a normally open circuit. When you wire your rapid shutdown in and you depress that button, it connects those two pins and it shuts off the output of the inverter. Shuts down the solar, it shuts down the and it shuts down the battery output of the inverter as well. Pins 7 and 8 can be connected to pins 4 and 5 in our generators to enable two-wire start. And so I'm showing you here in our generator connections, you would use these two pins 4 and 5 to connect to pins 7 and 8 in the Sol-Ark. And when those batteries get down, you can set when you want that generator to kick in. But those batteries get down, the generator can kick in and charge up those batteries. The other connections that are here are for CTs. So if you want to monitor the power being drawn from the grid and offset that with batteries, you can do that. I don't remember which pins are, or which connections here are for the CTs, but you can wire these CTs into the smaller pinout. And I do have that, the reference for you on the screen as to what these pinouts are. You can also find this, of course, in the manual. So CTs are being shown on the right side of the screen there. And again, the CT is on the screen there, pins 3 and 4 and 5 and 6 for the CTs. You do have to pay attention to the direction, the orientation of the CTs as well. So if you're installing CTs, make sure you use that arrow, and you'll either have to point it to the grid or away from the grid, depending on the type of connection that you're making. So when you are installing a system and about to commission, you're going to want to program in the battery settings. I recommend you follow our integration guide for this. And I've put that Sol-Ark, I've linked that Sol-Ark integration guide at the bottom of the screen. If you don't have that and want a copy of it, of course, we can also provide it to you by email. So you can program the battery info into the Sol-Ark after you have all those connections made by hitting the battery setup. So the basic setup, you'll have the option to turn off the beep in that section. You'll have the option to change things like time, etc. in the basic setup. But here in the battery setup, we want to get into, so you'll click the settings icon, then you'll hit the battery setup, and that's where you're going to enter the information. If you're using our communicating batteries, make sure to check this box, BMS lithium battery box. That will tell the inverter to look for that CAN bus communications coming from the batteries. You can also manually program these settings. So if you check this box, the settings should be auto-programmed for you for charge and discharge, etc. These are global settings. So if you set that battery capacity and a max amperage charge, that means from any source, whether it's from solar or from grid, etc. And this max amperage discharge, that's a global limit, right? So that's the maximum that'll allow those batteries to discharge. If we click the charge tab at the top of the screen and go into the charge setup, you can set things like the starting voltage. Now, keep in mind when you're programming a Sol-Ark, you can either set the system to use voltage or battery percentage. And so if you have it set on battery voltage, then the percentage section is going to be grayed out for you. You won't be able to change that. So if you're going to do your settings in voltage, I would recommend that you come in here and you can put those settings in. If you're using the BMS feature, these settings will be auto-populated for you. These are the settings associated with charging the batteries. These are the settings associated with charging the batteries from grid if you have that box checked. If you have the gen box checked, you can change the settings here for the generator settings. If you don't have a generator connected, obviously you won't check this box. This grid charge box being checked allows the inverter to charge the batteries from grid once they get down to, in this case, 49.5 volts. That maximum here is the limitation. You can set a different limit for how quickly the battery is charged from grid. I could set this to 50, even though I have the maximum global charging limit set to 100. This means if the inverter is charging from the grid at 50 amps, it could also be charging from solar at another 50 amps. The float volt for all of our batteries is 54 volts. The absorption setting should be at 56 volts, and the equalized setting we do not use. You'll set that time to 0 hours. Another important thing to set up is when you get into the discharge settings of the battery, that top tab, you'll want to set that battery resistance. If you're typically discharging these batteries in cold environments, you might want to use a slightly larger resistance. For our batteries, our batteries are about 24 milliohms divided by the number of batteries you have, because if you have batteries in parallel, the overall resistance of the bank is less than the resistance of an individual battery. So you can set this here. You'll also want to set this battery empty percentage. What that'll do is it'll prevent the batteries from shutting down. It'll make the inverter shut down before the batteries do, to prevent over discharging those batteries and have that hard stop when the batteries go through a shutdown. Under grid setup, so after you finish programming the battery setup, you can set up the grid setup in the inverter. There are a number of nice features. We don't have time to get into all of the things like time of use, but I've linked a nice video for you about how to do time of use settings. So there are different limitations that you can do. You can sell back to grid. You can choose, you can use limited power to the home. This is also a common feature. If you use limited power to the home, you can use CTs to limit the amount of power you're drawing from the grid and produce more of that from your batteries. You can also do time of use, and you are allowed to set up different times where you're discharging your batteries at rates that you can program in during certain windows of time. So I can program different powers. I've got them all set to 2000 right here, but you can program in different rates at different times of the day. Under the grid input, most typically you're going to have 60 hertz if you're here in Canada, Mexico, or the US. 120, 240 split phase is the typical power that we draw here. However, these inverters can be used with three-phase systems. You can use a single inverter to do 2 of the 3 phases. You can use 2 inverters to do 3 phases, but then they wouldn't be balanced. And then if you want to have balanced 3-phase, you can use 3 inverters or combos of 3, 6, or 9, or 12 inverters for balanced 3-phase. You can parallel up to 12 of these inverters, both in split phase or 3-phase configurations. In terms of parallel, when you have parallel inverters, you are going to want to set up one master on each of those phases. And so you'll do that from that parallel screen that's under the basic setup tab. And we will come out with a training later on to describe how to do parallel systems in more detail with our batteries. It's more of a Sol-Ark feature than a SimpliPhi feature, but we do sell a lot of Sol-Ark inverters with our batteries. Daniel, are there any questions I should take now?
We have a couple. They're kind of specific, so I'm going to hold them to the end. We have about 2 minutes left.
Yeah, I realize we're really short on time. Here's a nice example with a couple of, looks like those are 12Ks paralleled together with a larger battery bank. I do want to highlight that our batteries have a built-in temperature system that allows us to use our batteries to lower overall temperatures than most of our competitors. And we do this by using the battery's own internal resistance to heat up those batteries and charge them at slow rates all the way down to negative 20 degrees Celsius.
And we did have some questions related to temperature earlier. And so, you know, a lot of times
Go ahead,
we
Daniel.
have additional trainings that dive a little bit deeper into this. Someone was asking, you know, if I'm up in Canada, can I work them in negative 20 degrees centigrade areas? And the answer is yes, but really, if you're down that cold, we're going to want to think about heating options for our batteries, which we do offer. But again, what you're showing here is the ability to slow the charge rate as well. So that's a whole hour conversation in and of itself. But it's
And that topic is coming up next week, Daniel. So if you're interested in extreme environments, we have a training next Thursday on utilizing our batteries in extreme environments. I realize I only have about 1 minute left. And so I'm going to jump into the Sol-Ark app just a little bit, kind of show you some screenshots. So you have a lot of ability to see independently, see AC coupled solar coming in, to see generator coming in, to see batteries charging, discharging, to see PV coming in. You can look at this at a day, a month, a year, and you can really customize what you're looking at when you're monitoring different systems. So this is an example of a system that I was involved in getting started and setting up and programming, and you can look at the battery over time going positive, positive when it's charging up, negative when it's discharging. So there's a lot of things that you can do with the Sol-Ark app. You can even look into things like payback period, etc. As I close here, so I know I'm out of time. I really thank you for your attendance. We'll get into some of these topics in more detail in the near future. I do want to highlight that if you're not registered as one of our elite installers, contact Daniel or I. We'd like to welcome you into the program. If you haven't installed one of our battery systems before, you can get $1,000 off your first install. And for those that are elite installers with Briggs & Stratton, it doesn't cost you anything. You get $100 cash back per battery that you install when you're part of this program. So please let us know if you're interested in participating in this program. We'd like to get you on our map, direct some of our customers your direction. Again, this is that $1,000 rebate. And keep in mind, we get that extra 20% off because we're a California manufacturer. So if you're installing our Phi or SimpliPhi batteries here, you get that extra 20% off. I'd like to highlight that we would love to get your feedback on this webinar. So if you can give us some feedback about how we could improve the training to suit your needs, please let us know. Use this QR code to give us some feedback, or use the link when I send out these slides. So thank you again. If you're here for these NABCEP credits, send us an email, energy storage training at basco.com or training-oxnard@basco.com. You can also reply to the link, reply to the email I'll be sending you that have these slides as well. So happy to get you those NABCEP credits. Please reach out to us.
Nathan, we had a couple questions earlier about sizing systems, not only for how long will loads run in an off-grid situation, but also what's the minimum number of batteries. So I just want to mention on our website, we do have resources and calculators that allow you to size this kind of stuff. One thing, a couple of the questions, if anyone needs a drop, thank you for your attendance. We look forward to seeing you at NABCEP out in Raleigh. Earlier, you had showed a picture of the Sol-Ark with that two.
I was trying to find yeah, go ahead, Daniel.
And the question is that if we have two separate battery banks, do we need to have two different comms ports, or is the one comm port able to communicate to both battery banks? So
you should not have two separate battery banks.
Well, I think what we're showing on that the Sol-Ark 15k has two battery breakers.
Yeah, but essentially you have one battery bank that is combined at that battery breaker.
So they're paralleled up there.
And yes, so great question. I'm sorry I didn't catch it first. So first thing is, because you're joining those cables at the location of the Sol-Ark, you are essentially combining those battery banks into one. So answer, easy. You only need one communication wire coming from one of those battery banks. You do want to make sure those battery banks are daisy chained together in terms of communication. Second comment, if you are doing two separate 2-aught wire gauges, 2 separate connections, make sure that the cable lengths on both of those banks are the same. That will keep your system balanced. So if you do 2 separate wire runs and combine them at the location of the Sol-Ark, make sure the cable lengths connecting those 2 banks are the same length. That keeps your system balanced.
Another question, and I'm not sure if I really understand this. Somebody's asking if they have an application where they're going to be sending about 70 kilowatts to a battery bank. And then at the same time, they like to be discharging at 70 watts continuously. Is that possible to accomplish with the Sol-Ark? I just want to mention we have a whole team of sales application engineers, 805-640-6700, extension 2. Call us and talk to one of our sales application engineers. They'll be happy to jump into some of those details with you. And
if you don't mind, I'll jump into the answer for that question.
Yeah, you can't really charge and discharge at the same time, but go ahead, Nathan.
Yeah, exactly. So a battery cannot both be simultaneously charging or discharging. Either the current's flowing into the battery or the current's flowing out of the battery. You can have if you have your solar array oversized, right, you can be charging your battery while powering, I think the number is 70 kilowatts of loads. And that is certainly a feasible number to do with Sol-Ark 15Ks. Remember, you can parallel up to 12 of these units. But the batteries are not simultaneously charging and discharging. They're doing one or the other.
Last question. Somebody's asking about the NFPA regulations for battery banks. And you know, I believe I read into that is the UL 9540, UL 9540A. We do have other talks where we kind of jump into that, but these are certifications that we have on our batteries, and again, reach out to our application engineers and we'll help us support any documentation you might need when you're looking to get the permit signed off. But keep in mind that safety has always been foundational to what we do here at Briggs and Stratton Energy Solutions, and we're really proud of some of our NFPA documents that we offer. Reach out to us and we're happy to help support you. That's all we have, Nathan.
Thank you. We're 6 minutes after the hour, so we understand that some of you may have dropped, and we thank you for your attendance. You'll get an email from me. Go ahead and reach out if you need those NABCEP credits as well. So thank you, everyone. Thank you, Daniel.
Yeah, thank you, Nathan.